So this is your review, seniors, for your next test. It just goes over 11.1 and 11.2. So the first 4 questions, it just asks you to fill in the missing entries in each table. For example 1, we have x and 2 to the power of x. For the first slot, we have a -2 for x, so we're just going to plug in that -2 for x. So we're going to do 2 to the power of -2, which is 1/2 to the second power, which is 1/4. Next, we have that x is what we're finding, and 2 to the power of x is 1/2. So 2 to the power of x equals 1/2. So we want to know what x is. X would be -1. Next, for 0, we would have 2 to the power of 0, which is 1, because anything raised to the power of 0 is 1. For the 4, yeah. So if you had an x, so 2 to the power of x is equal to 4, it would have to be 2 to the second power, so x would equal 2. And then that 3, if we have 2 to the third power, it just gives us 8. For number 2, we have x and we have 1/2 to the power of x. When x is -4, we're going to have 1/2 raised to the -4th power, which is 2 to the 4th power. 2 to the 4th power is 16, 8, 32. No, 2 times 2 is 4, times 2 is 8, times 2 is 16. I was right the first time. When we have that 1/2 to the power of x is equal to 4, that x is going to be -2. When we have 1/2 to the first power, it gives us 1/2. That 1/2 to the power of x is equal to 1/4. That x is going to be 2. And lastly, the 1/2 to the 4th power is going to be 1/16. For example 3, we have x and log 4 of x. So this is going to have or give us log 4 of 16. So 4 to what power is 16? It would be 2. So then next we have log 4 of 1. So 4 to what power is 1? That would be 0. Next we have log 4 of 1/4. So 4 to what power gives us 1/4? That's -1. And lastly, we have log 4 of 1/16. So that's 4 to what power is 1/16? Well, that would give us the -2. For number 4, we have x and we have log 1/2 x. For our first x value, we have 32. So we're going to have log 1/2 of 32. So this is saying 1/2 to what power is 32? Well, if we raise 1/2 to the -5th power, we get the 32. Next, we have log 1/2 of 16. So 1/2 to what power is 16? If we raise 1/2 to the -4th power, that would give us the 16. Next, we have log 1/2 of 1. So 1/2 to what power is equal to 1? That's 0. And then lastly, log 1/2 of 1/8 is 1/2 to what power is 1/8? If we raise 1/2 to the 3rd power, that gives us the 1/8. For number 5, we're just solving for x. We have 3 to the power of x is equal to 81. If you remember, if you have both sides with the same base, those bases will cancel out, and you just have to use those powers in order to solve for what x is. So the 3 to the power of x is not going to change. However, 81 is 3 to the 4th power. So now because our bases are the same, they can cancel out, and you can just work with your exponents, which give you x is equal to 4. For number 6, we have 1/2 to the power of 3/8 is equal to 8. We know that that 8 is 2 to the 3rd power, so we can rewrite this as 1/2 to the power of 3x is equal to 2 to the 3rd power. That 2 is not 1/2. You can make it into that 1/2 by raising it to the power of -1. So we're going to have 1/2 to the power of 3x is equal to 1/2 to the power of -3. Because your bases are the same, they cancel out, and you're just going to work with the 3x is equal to -3. Divide each side by the 3, and you have that x is equal to -1. For number 7, we have 10 to the power of x is equal to 0.01. This 1 that we have in our decimal is in the hundredths place value. So this is the same exact thing as saying 10 to the power of x is equal to 1 over 100. That 1 over 100 is the same exact thing as saying 10 to the power of x is equal to 10 to the power of -2. So your bases are the same. So we're just going to work with x is equal to -2. That x is solved for here. So for number 8, we have log x of 64 is equal to 2. If you remember, this is the same thing as saying x to the power of 2 is equal to 64. So to find what x is, we would do what is raised to the power of 2 to get us to be that 64. If we have 8 to the 2nd power, that gives us 64. So our x is equal to 8. For number 9, we have log x is equal to 4. You do not have a base for this one. So it is understood that our base is 10. So this is the same exact thing as log 10 of x is equal to 4. If we rewrite this in exponential form, this is 10 to the 4th power is equal to x, and 10 to the 4th power is 10,000. For number 12, we have m is equal to log 5 of w. Now with these, we're just rewriting them using exponential form or vice versa. So to write this in exponential form, I'm going to actually rewrite it to where I have log 5 of w is equal to m. Now I have that 5 to the power of my answer, which is m, is equal to w. Our next question for number 13, we have a to the 3rd power is equal to y. So we're writing this one using our log form. So our base is a, our answer is going to become 3, and our whole number will become y. So this is just going to be log a of y is equal to 3. For number 14, we're given f of x is equal to 2 to the power of x plus 1. These x values are, I'm going to, again, the way this question is going to be done, your graph will be given to you. You're picking the equation that matches it. So you'll just have to plug in x values to each of the functions if you want to, and pick the one that matches the ordered pairs that you see on the graph. For this one, though, I'm giving you your x values, so we're going to use -1, 0, 1, 2, and 3 for those x values. So this is just going to give us 2 to the -1st power plus 1, 2 to the power of 0 plus 1, 2 to the 1st power plus 1, 2 to the 2nd power plus 1, and 2 cubed plus 1. That 2 to the -1st power is 1/2 plus 1, which is 2 over 2, so that's going to give us 3 over 2. 2 to the 2 to the power of 0 is 1, plus 1 is 2. 2 to the 1st power is 2, plus 1 is 3. 2 squared is 4, plus 1 is 5. 2 cubed is 8, plus 1 is 9. So this is going to give us -1, 1/2. That's going to be here. 0, 2, 1, 3, 2, 5, and 3, 9. So to draw our line, we use these ordered pairs, and it just curves and goes up as you go to the right. For number 15, we have g of x is equal to 1/2 to the power of x minus 3. This is the same thing as y is equal to 1/2 to the power of x minus 3, and I'm giving you x values of -2, -1, 0, 1, and 2. So this is going to be 1/2 to the -2nd minus 3, 1/2 to the -1st power minus 3, 1/2 to the power of 0 minus 3, 1/2 to the 1st power minus 3, and 1/2 to the 2nd power minus 3. So this is really the 1/2 to the -2nd is 4 minus 3, which is 1. The 1/2 to the 1st power, or the -1st power, is 2 minus 3, which is -1. Then we have 1/2 to the power of 0, which is 1 minus 3 is -2. 1/2 to the 1st power is 1/2. Minus 3 is 6 over 2 to have those like denominators, so it's going to be -5 over 2. And then that 1/2 to the 2nd power is 1/4. Minus 3, which is 12 over 4, is going to give us -11 over 4. If you want to, this -5 over 2 is the same thing as saying -2 and 1/2. And that -11 over 4 is the same thing as saying -2 and 3/4. So when you go to graph these, you're going to have -2, 1, -1, -1, 0, -2, 1, -2.5, and then 2, -2 3/4. So this is going down as it goes to the right. Oops. And up as you go to the left. For our last example, number 16, we have y is equal to log 2 of x. Our x values that I'm giving you are 1/4, 1/2, 1, 2, and 4. So this is going to give us log 2 of 1/4, log 2 of 1/2, log 2 of 1, log 2 of 2, and log 2 of 4. So we're going to do 2 to what power is 1/4? That's going to be the -2nd power. 2 to what power is 1/2? That's -1. 2 to what power is 1? That's 0. 2 to what power is 2? That's 1. And 2 to what power is 4? That's 2. So we have 1/4 -2. So 1/4 -2 is about here. 1/2 -1 is about here. 1, 0 is here. 2, 1, and 4, 2. So this one gets closer and closer to that y-axis, but doesn't cross over it. And then as it goes to the right, it's moving up. So your asymptote there is that y-axis.